Welcome to the Computing and AI for All Rationale and Curriculum Overview. The premise of our work. Computer science is the critical discipline of the 21st century. It is also the most unequal. Changing this requires systematic integration into other content area curriculum. But high school is too late. Computer science must start in elementary school when students are curious and interested in learning new things. Are our students ready? And more importantly, are our teachers ready to teach computer science in their content area curriculum? The Computing and AI for All Impact Team has spent the past 5 years developing curriculum, researching, and training teachers to infuse computer science into their content area curriculum. We are a combination of educators and researchers from the University of California, Irvine and the University of Chicago. Computing and AI for All, formerly EC for All, is a partnership between University of California, Irvine and the Southern California school districts to meet the challenges of the 21st century in bringing computing into the elementary school classrooms. We've developed a curriculum that combines computational thinking and culturally relevant pedagogy with language and literacy, environmental science and data science, and AI in literacy. We've developed supports for teachers, so even those teachers with no experience in computer science are able to learn it and teach it effectively in their classrooms. We have continuous evaluation and improvement infused in the curriculum as a way for students to better understand and master computer science skills. Our curriculum is made up of 5 different units. Act 1 focuses on foundations of Scratch coding for 3rd to 5th graders. Act 2 takes the skills that were learned in Act 1 and builds on them with more advanced computer science content suitable for 4th and 5th graders. Act 3 builds on the skills that were learned in Act 1 and Act 2 and includes more advanced computer science content best suited for 5th graders, along with a community-based environmental science and data science literacy unit. Act 4 is a coding plus AI literacy-based curriculum based on the Create-A-Code platform, suitable for 6th grade and above. Scratch Basics is a 6-week introduction unit to Scratch for those who have never used Scratch before or need a refresher in learning the Scratch basics. We also include a link to Coding as Another Language using Scratch Junior for students from kindergarten to 2nd grade. There are 5 main 21st century skills: creativity, collaboration, critical thinking, communication, and computing. Computing is interchangeable with the term computational thinking. Computational thinking is thinking or problem solving like a computer scientist. It is the thought processes involved in understanding a problem and expressing its solutions in such a way that a computer can potentially carry out the solution. Computational thinking is thinking or problem solving like a computer scientist. Computational thinking can be broken down into practices and concepts. Practices include problem decomposition, breaking a problem down into smaller parts so it's easier to understand and easier to solve. creating computational artifacts, actually being able to use the computer to create things such as animations, instructions, or programs, testing and debugging, testing and debugging, testing the computational artifacts that have been created to ensure that they meet the intended solution, and refining them through debugging until they do meet the intended goal. Iterative refinement, which is constantly refining our code and our solutions to make sure that they are the most effective and efficient solutions. And collaboration and creativity, which is a life skill, and our computational thinking concepts encourage collaboration and unique ideas placed into solutions. These are the practices that our students are actually doing. The concepts that they are learning while they're doing these practices are logic and logical thinking, algorithms and algorithmic thinking, patterns and pattern recognition, abstraction and generalization, evaluation, and automation. Computational thinking and coding should start in primary school because it can help prevent possible misconceptions. We did a study and we asked third, fourth, and fifth graders what they thought a computer scientist looked like. And what do you think they said? They described someone in a white coat or jacket, and most likely male, which was about 70% of the responses. Because of this, in our curriculum, we have included computer science role models, the majority of them being women, in order to overcome this misconception. These role models also came from diverse backgrounds to represent the broad range of backgrounds of our students. Our curriculum empowers students to be creators of technology and not just users of technology, to think about how technology works and not just use it in their everyday lives. Computational thinking is a perspective to see the world in a different way. As with learning natural languages, it's beneficial to learn coding from a young age, which is why we start this curriculum in primary school. The curriculum also provides opportunities for both teachers and students to integrate coding into the content area curriculum to make it part of the normal learning process.